Beloved geometry students, this is the help video for the Algebra 2 preview review packet that has been provided for you in the last and final email in this class. This preview packet has been carefully crafted by the Algebra 2 teaching team and includes basic concepts that are absolutely essential to you to have mastered going into Algebra 2. Most of these concepts are Algebra 1 based. Realistically, we understand that most of you need an Algebra 1 review in order to recall and master this information. You are responsible to work through this packet in detail, showing all your work on this grid paper. You can print additional pages as necessary. And then graph grids have been provided for problems 32 through 35, 36, and 41. Work in pencil, correct in red pen, marking star smiley things you get correct, and redo the problems in red pen in the margins of the ones you get incorrect. Demonstrate that you have actually mastered the material. This video will go over only the bold problems to give you a little shove in the right direction. Taking a look at number 4. The instruction says evaluate each expression. We are following the classic PEMDAS. Please excuse my dear Aunt Sally. You work parentheses, exponents, multiplication, division, and then addition and subtraction. So following that order, we're going to come right here and we're doing problem number 4. So the key thing here you need to keep in mind is this division sign. It is much easier to work this problem if you switch that division sign to a fraction. So this division sign is going to become a fraction. And what we have here in the numerator is this 20. And in the denominator, we have the rest of this expression. Those parentheses are really important. So I'm going to focus strictly on this step by step. Step 1, we're going to do the parentheses. So this becomes 4 minus negative 10 plus 8 becomes negative 2, and this entire thing is still squared. Then we do that exponent. So this down below, this becomes double negative makes a positive 6 squared, and that exponent is 36. So the final expression here is going to be 20 over 36. But wait, there's more. Each of these is divisible by 4, of course. You always want to reduce. So your final version here, 20 divided by 4 is 5. 36 divided by 4 is 9ths. Yes, fractions are perfectly acceptable. Says simplify these exponents. Your answer should only contain positive exponents. A word about exponents if it's been a long time since you've seen these. Couple rules here. exponents does not mean, so x squared is not 2x. It's x times x, just as a refresher. So be very careful that you don't read this as a 2. It's not a 2. It means times it by itself twice. Also of note is that x to the 0 exponent is 1, as long as your x itself is not 0. In other words, 0 to the 0 power is still 0. Next thing you need to remember is that a negative exponent means it turns into a fraction where this goes in the denominator. So x to the negative second power is 1 over x squared. So the numerator goes into the denominator. So those are some of the rules that we're working with this problem. Keeping that in mind, let's work through this problem right here. So first off, I see that -3. That means this entire expression is going to go into a fraction where I have 2x to the 0, y to the second cubed, and then this stays in the numerator. Now you start simplifying. First thing I recommend you simplify is that all exponents you expand. So watch what I mean by that. This becomes 2y x times x times x. That's x to the third. Okay, down here, this is going to be 2 times 1. Where did that 1 come from? X to the 0 power is 1 times y times y. And then we do that 3 additional times. So watch carefully. That's 2y times y. Boom. 2y times y. Notice I'm not rewriting that 1 there because obviously that's not meaningful. Now you cancel where possible. For example, since there's no plus or minus sign, I can just do this. The 2's cancel, and at least one set of y's cancel. Now I kind of combine what's left. What's left is in the numerator is x cubed. In the denominator, I have 1, 2, 3, 4, 5 y's and a 2 times 2. So that's going to be 4y to the 5th power. There's nothing else to reduce or cancel, so you're done. Problem number 20. Your Algebra 2 teachers are going to show you some super nifty shortcuts to these types of problems. I'm going to go at a more traditional method, and the instructions here was simply to factor. Couple observations. When it's negative here and positive here, we automatically know that your factoring is going to consist of a negative times a negative, because double negative makes a positive. A negative times a negative gives us that positive. So just keep that in mind, that we're basically going to be adding negative numbers. So the way I look at this is I factor this first and second. So the factors of 5 are 1 and 5. The factors of 9 would be 1, 9, and 3 and 3. And then I'm simply looking for combinations that add up to 18. Now if I go like this straight across, 1 times 1 is 1, and 5 times 9 is 45, and that would, if we were to add those, would give us 46. That's not 18. That doesn't work. If I go like this, 1 times 9 is 9, 5 times 1 is 5, 5 plus 9 is 14. That doesn't work either. That doesn't give us 18. So we know that the 1 and the 9 cannot be factors here. Let's try this. 1 and 3. 1 times 3 gives us 3. 5 times 3 is 15. If I add 3 and 15, lo and behold, check. I know that those are the factors involved. So the way I set this up is I have the 5 has to go with a 3. So I have 5x and x and a 3 and a 3. Super important that you FOIL and test. Super important that you FOIL and test. So foiling, that's going to be 5x squared minus 15x. Foiling this way, negative 3x plus negative 3 times negative 3, 9. Now we just combine like terms, and I get 5x minus 18, x plus 9, and there is my check. It matches. It's always good to go back, factor, and check. Next problem is 24. We're going to be a couple rules about multiplying and simplifying radicals. Basically, the rule is this. Anytime, if you were to factor it out, anytime you have a double of anything, something times something, of the exact same thing, it pulls out as a single one. The phraseology I used in my class is if you have a date, you get to go out. But when you go out as a single couple. Therefore, taking a look here, also when you multiply radicals, so looking at 24, this is going to be one giant radical because it's times, not plus. And this is going to be 20x squared, and that's times 20x. I'm going to pull that apart a little. So it's all multiplying, so I can rearrange it. I have a 20 and a 20, an x, and another x. Now, your dates come out. I have a pair of 20s, and I have a pair of x's. So my final expression here is going to be 20x root x. Ta-da! You're done there. Taking a look at the next problem. We're going back to a geometry standard, which is slope. So finding the slope using a pair of points. Remember the slope equation. Slope equals rise over run. Rise, you subtract the y's. Run, you subtract the x's. Again, the traditional equation is y2 minus y1, x2 minus x1. That is not significant. What is significant is if you start left to right, you finish left to right. If you start right to left, you finish right to left. That is what is significant, is consistency of the direction. So for this one right here, I taught you to always make a template first. So there's your template. Template first, then you plug in your numbers. That helps you catch the double negatives. So I'm going to work left to right. Y minus y. Left to right, x minus x. Double negative makes a positive. Negative 18 plus 18, that's 0 over 27. But 0 over any number is just 0, and 0 slope is a horizontal line. Keep that in mind. Any number over 0 is undefined, which means it is a vertical line. Graphing. Graphing inequalities. We're going to do this one together. So graphing y is greater than negative x minus 5. The first thing you want to do here is you pretend this greater than sign is an equal sign because you're more familiar with graphing using an equal sign. So we're going to go y equals negative x minus 5. Right underneath that, we're going to write y equals mx plus b. Step 1, our b-intercept, which is our y-intercept, is negative 5. So we start down here at negative 5. 0, negative 5 is our y-intercept. Our slope is essentially negative 1 over 1. Which means our line must tilt downward. So down 1 over 1, or up 1 over 1. Now when we draw this line, because it is greater than, technically it does not include this line I'm about to draw. So imagine if I drew this line like this, which is what you're used to doing. The problem is, because it's a solid line, that represents the whole concept of equal to. But there is no equality here. So we do not use a solid line. Instead, because it's greater than whatever this is, we have to use a dashed line. Dashed line means start here but not include this. So when you graph, you would use a dashed line. And what's included is everything on the y-axis that's greater than this line. So that would be going roughly this direction. Not roughly, it is. Every value of y greater than that line. So you would shade that aspect of your graph. Solving systems of equations using elimination and substitution is a very critical skill. Elimination is exactly what it sounds. You attempt to eliminate a variable. I'll do 38 with you. So you analyze and see any way you can manipulate these equations so that a variable cancels. So I'm looking here at my x's, and I'm looking here at my y's, and it really doesn't matter which one I start with. But I notice, since this is already negative, if this were to be a positive 4, it would cancel. So to manipulate this equation, I have to multiply everything by 4. Because whatever you do to one variable to keep an equivalent expression, you have to do to every one of them. So we're going to multiply. We're going to recreate this as an equivalent expression. So I have negative 4x All right, now, when I add these, I see my x's now cancel. So 9 minus 12 is going to be negative 3y. And 9 minus 24 is negative 15. So y is going to equal positive 5. Now to solve for the x, you simply plug it into either equation. So I'm going to plug into the second equation, x minus 3y equals negative 6. It's going to be x minus 3 times 5 equals negative 6. And I solve and I get x equals 9. So my ordered pair solution is 9, 5. But wait, how could you be absolutely sure you're correct? 100%. We're going to take these values and plug them into the other equation to double check it. So right here in the margin, we're going to go like this. We're going to go negative 4 times 9 plus 9 times 5 equals 9. Just to recap, what I did is I took that x and I plugged it in there, and that y and plugged it in there. Now, you work it out. And 45 minus 36 is 9. 9 equals 9. There's your check. Taking a look at 42 here, it says to find the zeros of the function. Now, you're like, you may not even remember what the zeros of a function are. What this is basically saying, I can tell by the way this is framed that this is what's called a parabolic equation, which means you have a graph and you have your parabola, and the parabola either faces up or down. There's a couple ways to determine which direction it's going. But when we talk about the zeros, we're talking about where does the graph, where the y is 0, and this f of x means the range after x is the domain, this would technically be your y. So where the y values are 0, so wherever the zeros are on a graph, that would be called the zeros of a function. So this point would be something in the x and 0 in the y, and this dot over here would be something in the x and a 0 in the y. So basically we have to solve what are the two possibilities for x, and there's two of them because unlike lines, a line is going to cross the x-axis, most likely, at a single point. But if it's a parabola, it's going to cross at 2. So that's what's going on here. So we come over here, and we're going to factor this equation. And we've already done factoring, so we're going to do it again. Now, of these styles, when you have something that looks like this, okay, and that's something x squared minus something x plus or minus something. Because that requires a double negative to get that positive, you know your factoring is going to look like this, two negatives. Now, if you have something that looks like this, something x squared minus something x minus something, that means our factoring has to be a plus minus combo. And the reason is, if you had two negatives, it would swap that to positive, but because that's negative, one of them is positive and one of them is negative. So we know we are working with this factoring. Keep that in mind. Technically, instead of adding factors, we're going to be subtracting. So coming over here, I factor my 1 here, which is just 1 and 1, of course. I have 6, which would be 1 and 6, or 2 and 3. Now keep in mind that we are technically subtracting two factors. So if I go like this, and I get a 2 and a 3, 2 minus 3 or 3 minus 2 is going to get me 1. So I know that doesn't fit my middle term here. So that eliminates these two. So I know that I have to go this way. 1 and 1 is 1. 1 and 6 is 6. And 1 minus 6 gets me the negative 5. Ding, ding. So that's the combo we know works. Now you just have to play with it a little bit logically to get negative 5. So watch carefully. I know that this is a plus and minus, and it's 1x and 1x, and a 1 and a 6. Because I want my larger number to be negative, because the middle is negative, I'm going to put my 6 here and my 1 there as my factors. Where do those factors come from? That's these guys. Now, do not be happy when you have that like you think you've solved it. Always FOIL it backwards and see if you did this correctly. That's going to be x squared minus 6x. That's going to be plus x minus 6. Combine like terms. X squared minus 5x minus 6. Check, check. You know you've got it. You're not done, because it did not say simply factor. It said find the zeros. So finding the zeros means you're going to do this. The zeros of the graph are 1x plus 1 equals 0, and 1x minus 6 equals 0. You solve. Minus 1. So one of my zeros is going to be x equals negative 1. And then I do this. I add 6, and x equals 6. Keep that in mind, that your zeros are negative 1 and 6. And let me demonstrate on this lovely website that I recommend you take a look at. We're going to take this equation right here, x squared minus 5x minus 6. On this website, and it's called Graphing Quadratics. I will add this, and now we're going to plot this. That was 1x squared minus 5x. So we have to go downwards. Minus 6. Now, taking a very close look at that graph, notice, 6. Got it. Looking very carefully here, that's x squared, technically plus negative 5, which is minus 5x minus 6. It matches. See that? It matches. Now watch. There's your equation. You can see right there. There's what we would call the axis of symmetry. And here, ta-da, are what are called the roots. Look very carefully at the blue. Notice what the blue says. Watch very carefully. Do you see that? Negative 1, 0, and 6, 0. Do you see that? Negative 1, 0, and 6, 0. That is exactly where the parabola crosses the x-axis. That is called the zeros. Students, if you actually stuck through to the end of this video during the summertime, that is the sound of me applauding you. Good job.